Hello, everyone. I'm sorry that I'm a little bit late. I was supposed to start at 12, but I was just sorting out technology. My name is Verena, and I will do the live stream on maintenance of earth buildings today. My background is in earth building. We have an earth building company here in Aotearoa, New Zealand, down in Nelson. So I will be drawing on quite a few years of doing maintenance jobs for clients. And this is the last of 4 live streams that I have been doing that are mainly concerned with durability of earth buildings. So it is a very big topic. And if you haven't already, you might want to check out the previous live streams I have done. They sort of all mesh in with each other and complement each other. As I said, it is a big topic, and today we're just rounding off with a few lessons learned and a few tips and tricks and discussions around the maintenance. So not so much like when I was preparing it, I had to really find the balance between just maintenance and then, going into historic buildings, which is a big topic in itself. So I will sort of cut it off at the level of historic buildings, even though there's an example of a historic building in there. And then we will talk about historic buildings as part of another live stream series in the future. Historic buildings are very dear to my heart. So I'm seeing you come on. Welcome. I'm excited to have a few of you on live. It is always easier for me to speak to people. So if you want to say hi and say where you're coming from, Esther, you've already done it. Great. Engagement sort of boosts the algorithm, so more people see it, shows up on their feed. So even if you're watching the replay, please let me know, where are you calling in from, where are you watching from, and just say replay. It's really exciting for me to see, when people rewatch it later on as well. So I am trying to get the technology to work this time. So last week, somehow the screen share didn't work, and I was looking at my screen and talking, but you were not seeing the screen. The slides are up on that live stream as a link. But today we're hopefully getting everything right, and I just would like you to give me the thumbs up if you see my screen now. And I think it will be easier to look at images while I'm talking to them, even though it is actually, I have struggled a little bit to find good images of maintenance jobs, because I tend not to take so many photos, and the photos are not that exciting. And then till you go and want to teach something, and then they will come in really handy. But actually making photos of earthen surfaces while you're working with them is kind of a little bit elusive and challenging. So let's have a look. Maybe this will be visible for you. So hi Gabi, hi Isa. If you could just give me the hands up, thumbs up that you're seeing my screen. I think you are, but give me a little notice, because at the moment I'm seeing the chat. Once I go into the screen share, I will not see the chat anymore. And then I would suggest that we do Q&A if there are questions about this at the end of the live stream. I'm very happy to stick around for that. So can you see? Can you all see? Yes, great. Okay, so let me go over to my presentation and start from the beginning. So as I said, it is this is the last of these 4 live streams that I've done. We have been looking at weatherproofing of earth buildings, and then specifically at lime plasters. Last week we talked about breathability, which is really important in this context, and today we're going a bit more into the maintenance of earth buildings. And I sort of see these 4 live streams being a unit and addressing issues of durability. So it is a big topic. Just wanting to sort of set the stage of what we're looking at. When we're looking at maintenance, we're looking at wear and tear, and we're looking at damage. And that's a little bit of a nuance. So wear and tear is just something that happens to the building. It would be expected over the duration of the building's life. Damage is sort of stuff that needs to be troubleshooted, that maybe wasn't detailed so well in the past, when the building was designed. So types of wear and damage could be things like erosion of the surfaces, delamination of the surface, so both of plaster finishes or of actual building materials, like the surface just sort of spooling off, cracks and holes. And with those, there's also this nuance. Some of the cracks are just kind of wear and tear and not so crucial. And then other cracks are structural cracks, and they would sort of qualify more as damage. Sometimes that happens after an earthquake or something like that. And then there's moisture buildup within the building. And just to give you a visual of some surface failures, and to launch right into the controversial discussion. So what you're seeing here is a surface failure on a cement stabilized mud brick building. So the actual bricks you see in the underground here, you see the brick. This has had a big multi-day rainstorm on it. The actual bricks actually also failed the durability requirements, but they didn't erode or anything because they were cement stabilized. What did erode and fail was the wash that was applied over this surface, which had two things on it. So trying to do the right thing in terms of waterproofing the building, a hydrophobic agent was applied over the bricks. So that is often silicone based. So that was applied, and then over the top of that, a cement clay slurry was applied, and it looked good, for a little while, for a couple of years, and then it started to fail. So it just started to flake off like this. And what happened when we looked at this, we had to prepare a report on it. And as part of the report, we had to propose a methodology of repair, of maintenance. And this is it's kind of a challenging situation, because this mud brick water repellent has been often gets applied over mud bricks, both cement stabilized mud bricks and non-stabilized mud bricks. In fact, we have used it ourselves, like in situations where we had to troubleshoot past things, not stuff that we were involved in, the design. But it was very commonly used. So often when we visit older mud brick buildings, there is this hydrophobic agent that has been applied. And it is something that is actually also applied over fired brick. So when you see red bricks, often they also have a hydrophobic agent applied to them, because clay materials just are porous. The fired bricks are not as porous as the mud bricks, but they are just porous. So often this silicone gets applied. And what a hydrophobic agent does is it penetrates into the surface, and then it lines every little pore with silicone. So you might be familiar with the silicone baking trays, for example, or like molds for soaps. And the reason why these molds are used is because you can pour something in it and nothing sticks to it. So it's very easy to get the mold off. It's hydrophobic, it repels. And the same thing, principle applies with the hydrophobic agent, the silicone-based stuff that gets applied to surfaces, penetrates all the pores, and then it actually creates a situation where water theoretically can't wick in, because it sort of just slides back out. The problem in the context of maintenance here is that pretty much anything else you want to apply to the surface, so not rain, but a finish, like in this case, a cement stabilized wash or a lime wash or whatever, also kind of struggles to stick. It sort of pearls off like off a duck's back, especially just, at the start of the life, just when the product is new. So it does sort of wear down over time. And that's when we typically also see that it doesn't work so well anymore and that maintenance is required. So this is one scenario. The other scenario is more like surface weathering. So you see here, this is a cement stabilized block. This is a cob block. There's poor detailing, but actually this building has been doing really well for about 20 years, and then we got called in before it got put on the market to do some an assessment of what is required for maintenance. And it looked, this is probably one of the worst places on this building. It had done well, but then there was the situation where there was spalling. So spalling is the actual surface of the material kind of blows off and starts to weather. So it's not kind of erosion with water so much. It is more like a delamination of the material, of the top surface of the material. And with cement stabilized materials, this is quite challenging to repair if you want the surface to keep looking the same. So you could definitely repair it, and then you would see the repair and you would have to maybe apply a wash or a lime wash or something over the entire surface of the building to make it all look uniform again. But it is very hard to repair a spalled cement stabilized block or a rammed earth, a cement stabilized rammed earth part that is damaged to look like the original, because the repair will have a different texture, slightly different color, and it is hard to get it to stick to a cement stabilized wall unless you use the same materials or a lime based repair. So you would really see that, and you would have to deal with that situation with a wash or a paint or something, a breathable paint. On the other hand, here, what we encountered this is actually a historic building, but I put it in here because it had done really well. So like the cob blocks, even though they were kind of weathered, they were still doing really well in this very exposed situation on the chimney even. But the whole thing had been covered with a lime cement or based, they call it bagging. So it's sort of just slurring on cement with fine sand. It also was a common way of finishing buildings. It's not great practice, in my opinion, and it's quite challenging to repair. So we took it off where we could. In some places it really sticks on. And often when you're repairing, you'll also find the situation where different things have been done to, over the duration of the building. So, and as we're learning more about earthen buildings and, repairing them, there's different schools of thought. And so you'll find layers of things happening often, especially in older buildings or in historic buildings. And here again, there was also hydrophobic agent present at some point, and it was quite challenging to do something to the surface. So you might already notice, the tone of voice. I'm not putting these examples into this cement stabilized materials too much, but maintenance is one of the reasons we don't like them. And this is because we get called into doing maintenance on quite a few cement stabilized buildings, and it is just way more challenging than doing maintenance on raw earth, on unstabilized materials. And it also seems that the cement stabilized materials often have more problems. They have more problems. They don't erode so much, but they have this spalling problems where the surface blows off, and sometimes they leak. So in the group, so in earth building school, the way we teach, we will only look at raw earth, so earth that has not lime or cement added to it. And the maintenance aspect is one really big reason for this. So yes, I mean, you have joined the group, you're part of the Earth Building Academy, some of you, so you know how I teach and you know my reasons for this. But for anyone watching that is curious, about this conversation, should we stabilize or not? There's definitely, it's two schools of thoughts. It's fundamentally a different way of earth building, and we have got our reasons why we don't like it so much and don't do it. So that being said, when we're maintaining and repairing, we do respond. It's not like we're not fundamentalist about it. So we do like to respond to the building, to actually honor what the building is about. And often, if it worked, and if there's only small repairs, we will repair like for like. So we will make similar mixes. Usually we prefer the lime stabilized mixes because they're more breathable. So yeah, I'm not big on adding cement to anything, but we will really respond to what is there and make decisions on a case by case scenario. So I'm saying this because when you're maintaining, you might have, maybe you have a cement or lime stabilized building and you still want to give it some love. And of course, you might buy a place and you might not know exactly what has been done to it. So you might encounter surfaces that have been treated with a hydrophobic agent, or you might be in the conceptual phase where you're deciding, should we go down the cement stabilized route or the unstabilized route, or how should we finish? Should we use a hydrophobic agent or not? And maybe some of the things that I'm touching on will help you with these decisions. So, whatever your situation, if you have questions, I'm very happy to discuss them and look at your individual situations. So just to explain this thing about the stabilizing and non-stabilizing. So with earth building, with the pure form of earth building, we're using subsoil. So we're using clay in the soil as our binder. So that's called cohesion. The binder is the stickiness in the material. So whatever you then do with the subsoil, whatever earth building technique you choose, it is that the magical component is the clay. So the clay can be activated, the cohesion, the stickiness in the clay can be activated with water, and it will absorb water and, become malleable and have the thing that sticks together. So here you see like the bigger particles are held in there, and then the only thing that happens is that it dries out, so it shrinks. So we have this expansion and shrinkage that we have talked about in previous live streams, but there's nothing else. There's nothing else. There's just the clay, and as such, this process is reversible. So you can have clay, add water, make a building material, build, it dries out, it goes hard. When you have to do maintenance, you can add water to the surface, you can wet a little bit, you activate cohesion again, you can fix with clay materials, and then it shrinks and it goes hard again. And that's repeatable indefinite times. So this process is reversible, and you don't have a degradation of the material with wet, when it gets wet or when it shrinks. It might, create cracks and all the things, we might not want this to happen too often, but in the context of doing repairs and maintenance, it is very useful, because you can imagine it's not like a surface that has had a hydrophobic agent that just repels everything. No, it's the opposite. We can just wet the surface, scrape out cracks, do what we need to do, apply something compatible clay-based, and it will bind and become one. So the pure earthen materials are really, really easy to maintain and repair. It's very easy to even do alterations, or just do a little bit of a touch-up. So that's the reason why we really like the pure clay without other binders, so without cement or lime binders, because when you're adding lime or cement into the mix, lime or cement overpowers the clay, and the lime and cement undergoes a chemical process that over time is finished. So it's not a reversible process. It sets, and then you have the thing, and you can't just wet the surface and reactivate stickiness of lime or cement. So it is fundamentally different. Talking of lime, so what you're looking at here is a lime plaster over a mud brick that had a little crack. So this is quite a close-up shot. So the crack is maybe 5 centimeters. It was a shrinkage crack that happened because the building was still, just moving a little bit. But here, you see, I've put this in for 2 reasons. I'm talking about lime and not mixing lime and clay. So really wanting to explain, I do like lime as a building material. I just don't like the 2 things mixed. Lime is useful for plasters. It's useful for lime washes and so forth. So here you see the situation of a lime plaster over a mud brick. Put it in because it needs a bit of maintenance. We've done a whole live stream on exactly this situation, lime plasters over earthen materials. So if you want to go and check that out, please do. Very compatible. Cement plasters over earth blocks or earthen walls, not compatible at all, bad practice. But these 2 materials not mixed with each other, just actually doing their different functions, are very good in combination with each other if carried out properly. In the case that you have a small crack, for example, I'm showing this in a lime plaster, but it could also be in an earth plaster. It could be in an earthen wall. So if you have cracks, what you do is you V out the crack. So we use sort of a grunty paint scraper, and we just run along the crack and clean it out. Maybe brush off the dust, and then wet that surface and fill the crack with a material that is close to the original material. So in a lime plaster, we would be obviously using lime plaster to fill this crack. If this was earth plaster, we would be using earth plaster. If it was a mud brick, we would also use earth plaster. Why? So why? Because when you're filling, you really want to avoid shrinkage. You want that whatever you fill into the crack to just stay put and not shrink. Not, otherwise you have more little fine cracks along the repair. And for that, you need to have kind of sandier patching mixes. So often, it's sort of something that is similar to a plaster. So with binders, either clay or lime, depending on what you're fixing. But you want to have something that doesn't shrink too much. And you throw it in there, or you push it in there with a small spatula, really get it in there. But I didn't want to go away. And then once it's in there, you take a damp sponge and you just rub over it so that it blends nicely. It just totally disappears. And if need be, you will then finish the surface the way it was finished before. So that is just for repairs. If you need to blend a little spot repair, you would try and not have to redo a whole surface. And that's quite easy with clay and lime based materials, because you can sort of fix with like for like. It's not that easy when you have to fix a whole spoiled surface, like a brick that has delaminated or something like that. So in this case, we would have fixed with lime plaster, and then we would have applied the silicate paint. I'm getting to that in a moment. So the yellow is not a lime wash, it is actually a silicate paint, which is a water glass based paint, very durable. On the note of the surface coatings, in regards to maintaining surfaces, I really want to share this. And this is, you might have heard me go on about this a few times, but it is actually one of the most useful surface coatings I have come across. And it is a mix of lime, just lime, the way you would make up lime wash, and cow manure. So no clay I added to this. The brown here is oxides. So we made the lime wash into something that looked earthy, because we had to match the original look of the building. But we only used lime and cow manure in this mix. And the reason why I'm sharing this is because this is the only mix, the only surface coating I am aware of, water-based surface coating, which sticks to siliconized surfaces. And it's very useful. So you can apply a few coats of that, and it's very nice lime wash to use. So for those of you who have used lime wash, it's kind of runny, splashes a bit. You have to apply many coats, and there's a bit of an art to it. By adding the cow manure to the lime wash, basically it becomes much more spreadable. It builds up nicely. It fills up little holes more coverage, and it slows down the drying, the curing of the lime. So it leads to a really nice finish that has not failed for us at all. At any time we applied it. And there's this added thing that happens with the cow manure, because cow manure has got casein in it, and the casein reacts with the lime and forms a casein glue. So there's added water repellency in this mix. It's not waterproof. So, look at the other live stream that I did about breathability. Like the lime wash is not waterproof. It's breathable, and it sort of stays put, but it does let water through, so it's not water repellent. But even though it gets moist with rain, it doesn't then get it doesn't get repelled from a surface that has been treated with silicone in the past. If the surface is, if this is the first thing you apply to a surface, even better. You don't have to worry about it. But even for siliconized surfaces, this works. So it is a very good little trick, this one. And on that note too, we teach about natural paints as part of our 3-month course. And some of the paints, you would be doing interior paints. I have been focusing on exterior situations with this live stream. Obviously, like repairs and maintenance on the inside of a building are much easier because you don't have the weather exposure. But it depends what kind of substrate you are applying a natural paint to. And these different, substrates that you would be encountering, on the exterior, maybe stone, concrete, earthen materials, masonry, lime plasters, and so forth. There are only a couple of options for these kinds of substrates. So the ones for the exterior are your silicate paint and your lime washes. Lime wash being the thing that traditionally gets used, but lime wash needs to be reapplied regularly. It is something that in the past was part of a maintenance regime, like every 1 or 2 years you would re-lime wash an exterior, where these days people don't really want to do that so much. And often, if the building requires scaffolding to access the facade, it's not really possible because of cost. So we really recommend the silicate paints. Silicate, so not to be confused with silicone. Silicate is a water glass paint. It's breathable, it's natural, and it is extremely durable. And it cuts down how much water penetrates through the paint coat. So it requires very little maintenance, and that's why we like it. It's also very matte, and it can be tinted, so it looks kind of similar to lime wash in that respect. But just to give you a comparison, so the paint, I think it's guaranteed for 15 years, but in use, we have seen buildings not requiring maintenance for up to 20 years, which is phenomenal, as opposed to lime wash, requiring maintenance every 1 or 2 years. So just wanting to put that out there. Little plug for silicate paint. And silicate paint, you need to, if you're interested in using silicate paint, not all silicate paint is equal. So we like using the company Keim, which has a very good and long track record and also is used on many historic buildings in Europe and other places. So Keim is a very good brand of silicate paint. Yeah, so, that sort of goes from looking at the difference between, what is maintenance and what is repairs, and really making sure, if you have repairs, that you address them, to discussion about surface coatings and decisions, how often you want to do maintenance. But as a general maintenance regime, it is good to, go around your building at least once a year and make sure that you check the gutters, because that's a point that I see so many places that have blocked gutters and then overflowing onto earthen walls or lime plasters, and that's totally avoidable, and it's bad news. So check your gutters, see if there's any cracks or holes you need to repair. If you catch them early, it's not a big deal. Assess the surface coatings and reapply them if necessary. So that's what we were just talking. If you have a lime wash, you might have to reapply it every 2 years. If you have a very, very exposed site and you're starting to see, like a telltale sign is that in a rainstorm, your surfaces start going dark. And that usually indicates that water is penetrating and taking a while to evaporate out. So that's probably a sign that you need to do something to the surface coating again. And check if there's any issues where water can ingress. So, around windows, windowsills, flashing details, and so forth. That should have all been addressed in the design stage, but sometimes you need to troubleshoot, And as always, I'm just going to leave you here with the mention of the New Zealand Earth Building Standards, because we really find that most buildings that are designed to these standards require very little maintenance. Very, very little maintenance. So to give you an idea, on our building was built in 2006, and on the exterior we have since had to repaint the weatherboard. The earthen walls were totally fine because we have constructive weather protection. We have a veranda. We had one really big weather event on the east side that washed away the clay finish that we have on there, and we just replaced that in half a day. It was very easy because we didn't have to do anything to the surface in terms of, getting hydrophobic agent off or, scraping. It was just reapplying clay material, which was very easy. We have decided against a lime plaster in our situation because we are very sheltered. If we were exposed, we would go for a lime plaster, for extra durability. And I have talked about these design principles in the first lecture, and just to show it again, when you design with durability in mind, you will reduce the need for maintenance, and it's all about, keeping moisture out. So you want to make sure that there's no rising damp, that you're adequately protected from driving rain and water runoff. Also that, there's no risk of inundation. And then you want to make sure that when you're using earthen materials, that you have done your durability tests on them, which are specified in the standard, and that you make sure that your walls are breathable, which we talked about last week. And just to finish off, a couple of examples of buildings that require little to no maintenance, and a couple of just quite opposite ends of the spectrum. So this is a building that we have done in Golden Bay. It has wraparound verandas as constructive weather protection and lime plasters as additional weather protection, finished with silicate paint. We anticipate this building not requiring any maintenance whatsoever for at least 15 years. Maybe, on the weather side, they will decide to reapply another coat of silicate paint at some point, but it has gone through very, very severe weather already with no sign of any problems. And on the other end of the spectrum, just leaving the earthen walls raw, as, for example, Martin Rauch does with his unstabilized rammed earth buildings, so very big rammed earth buildings in Europe. They don't get the driving rain on the walls the way we do in New Zealand, so it's not totally comparable to places with very heavy driving rain. But I would suspect even in very harsh conditions, these walls would still be doing quite well. And the reason for that being is that the materials are performing well. So their material testing has ticked all the boxes. They use very gritty material for ramming, and they accept, so you see this on the right here, they accept a certain amount of weathering on the surface until the surface has sort of found a balance. So you see here in the corner, it's more sheltered, and then as you go further to the right, you see there has been some erosion over time, but that sort of stops there. When the clay has been washed away from the surface and it comes to the gritty, stony stuff, it will just sort of stay put. And they also put in these strips here, which are basically drip edges, which slow down water runoff over the facade. And they have worked with unstabilized materials. So let's say, at some point something falls out. They are able to wet the surface, reactivate cohesion, and just ram in similar material to the original material, blended seamlessly, and maintain the building that way. This is actually what they do now. In the company Rauch produces these really big prefabricated buildings, and then they crane them into place and they join them by wetting the joints and ramming in material for a seamless look. So the same thing would be done if they had to do maintenance on these buildings. And I just wanted to put it in there to show you, depending on your material, depending on your design, depending on your climatic conditions, you make your choices, and then repairing unstabilized materials is actually quite straightforward. You just have to be realistic about how often you want to do maintenance for what materials, and design accordingly. So I hope this has given you some ideas, and I'll just circle back and come back on and just have a look. How is this? Are there questions? If there's no questions or questions come up later on, just pop them into the chat and I will have a look at them when they come through as notifications. The maintenance is a big thing, and I'm aware, like maybe I've got this hat on of doing maintenance for other people. Like private situations might be slightly different. So I hope this was useful. I guess like the main thing I would like you to take away is to decide, when you're making material choices, think about maintenance and be realistic about it. Do your constructive weather protection, design in a way that you minimize maintenance, and then keep up the maintenance because these buildings can live for hundreds of years when maintained well. So that's the beauty. And definitely the unstabilized materials are much easier to maintain. And whatever you do, another little tip is to keep records of what you've done. If you've used certain products, if you have certain recipes, write them all down and keep record of them, because it is the bane of our life to come to a place and not know what was done. So by now we have sort of built up a repertoire of experience with them, but if people would keep records of the maintenance schedule and the products and the techniques and so forth, it would just be so much easier. Okay, I hope you have a wonderful rest of your day. I wish you all the best. Bye. I will just make sure that I have it. Yes, Esther, I just see the Keim. So Keim silicate paint, I will put the link underneath this live stream because then it will be useful for others as well. I'll put it in the website and just the product sheet. Wonderful. Okay, bye. Take care.